Hey guys, this video is going to cover section 7.2, the law of cosines, which can be used to solve the other two cases that we were looking at in the previous video for 7.1. The side angle side case uses these three different law of cosines formulas. They're actually all the same formula. They are just rearranged slightly depending upon which angle it is that you actually know and which side it is that you're actually looking for. Okay, the other two sides will be known. So it just kind of depends on what particular case and what you know and what you don't know for your triangle, the triangle that you have. All right, so in the example we're fixing to do, we're actually going to use that top one. A squared is equal to b squared plus c squared minus 2bc cosine A. Okay, because in this problem, example 1, we know angle A and side C and B. We're looking for side C and angle, or side A and angles C and B. Okay, so that formula was A squared is equal to b squared plus c squared minus 2bc cosine A. Okay, so we plug in what we know. A squared is going to be equal to B is opposite angle B, so that's 25 squared plus 32 squared minus 2 times 25 times 32 times the cosine of angle A, which is 60 degrees. Okay, so what we'll do is plug all that in the calculator and get a value for A squared, and then you can take the square root of that and get A by itself. Okay, if you've got a calculator that will do all of that at once, you can do that, or you may have to do each individual part as you go. The calculator that I'm using is just a cell phone calculator, so it's not as good at doing some of this stuff as some of the other calculators would be. So I'm going to go ahead and work on little pieces of it and then put it together at the end. That is 25 squared, and then 32 squared is 1024. 2 times 25 times 32 is 1600, and that'll be multiplied times the cosine of 60. So I've got 625 plus 1024. Those two go together to give me 1649, and then I'm going to be subtracting 1600 times the cosine of 60. So I think I'm probably finally at the point where I can work on some of this. Let's see, 60 cosine times 16 equals, make that negative, and then add that to 1649. Forgive me for talking out loud while I'm trying to plug this in the calculator. What I get for that is not what I expected to get. So maybe I didn't do that right. Hang on 1 second. Sorry. 1600. I think I just typed in 16 instead of 1600. I think that's the problem. 60 cosine times 1600 is equal to, change the sign, get to 1649. Yep, that's what I did wrong. Okay, that's a little bit more sense here. All right, so if I round this, this would round to 849. And if I wasn't on such a, I was on a little bit better calculator, I probably would not round that, so I might get a slightly different value. Then we take the square root of that to get just A by itself. And this is a side, so looks like two significant digits. I have 29 inches for that. 29.1376, if you want to go a couple more decimal places. So now we know this side, 29 inches. Now, to find the other two angles, you can employ another law of cosines, or if you'd rather, you can do law of sines, which is what I'm going to do here, because law of sines tends to be a little easier to operate with than law of cosines. Cosines is more complicated. Once we find one angle, then we can just subtract the two we know from 180 to get the third. So we really only need one more angle, and I'm going to do B for this. We know a matched set in our A and side angle A and side A. So I can do, if I'm looking for angle B, I'm going to put the sines on top. So sine A over A is equal to sine B over B. Plug in our values. Sine 60 divided by 29 is equal to the sine of B, which is what I'm looking for, divided by 25. So multiply both sides by 25, and of course we're looking for the angle measure, so we're going to have to use the arc or inverse sine to find B. Okay, let me scoot up just a little bit and we'll get that going. So what I'm going to do, because the calculator that I have, I am going to go ahead and calculate this part, and then I'll round it to a couple extra decimal places, and then we'll plug it in, maybe like 4 decimal places or whatever, and we'll plug it into the inverse sine to get it from there. So let me see here. I need to do the sine of 60 times 25 divided by 29. And what I get for that value, if I go several decimal places, 0.7466, and then I do inverse sine, which is just second sine on my calculator of that value. I just go ahead, in fact, I didn't even have to round it to put it in my calculator. I just left it alone. So this is what I actually wind up getting for B without the rounding. So if you did actually round and stop and put it back in, you may get something a little bit different. Our angles are rounded to the nearest, well, we really can't tell, can we, because it's 60 degrees. So we'll go with the nearest degree measure, which would be 48 for B, 48 degrees. And then, like I said, C is easy. C is just going to be 180 minus the 60 for A minus the 48 for B. So 180 minus 60 minus 48 is 72. So angle C is 72 degrees, and that finishes our set, okay? I didn't write all of our set down this time like I have been doing on the others. So I'm just going to circle them where they are. That's side A, that's angle B, and that's angle C. So those are 3 missing parts for this one. Now, this is the other version of the law of cosines. It is the form that you'll use if you are looking for, or if you have a side, and it's an angle measure that you're going to look for. Since you're not given an angle, then law of sines is out completely. And you have to have law of cosines solved for the cosine of the angle in order to make it work also, okay? So we'll use one of these forms. And here is our problem. Looks like we've got A is 34, B is 20, and C is 18. So it really doesn't matter which one we solve for first. It just says solve triangle A. Okay, I just went back and grabbed the one for cosine A. And we'll start with that, and then once you find your first angle, you can work the rest of it like we did the previous problem. You can either use law of cosines, law of sines, either one, and then once you find that second angle, you can find the third by doing 180 minus the other 2. It's pretty easy. So here I've got B is 20 squared plus 18 squared minus 34 squared over 2 times B times C. All right, so if we do that, 20 squared is 400 plus 18 squared, 324 minus 34 squared. Oh, and I didn't think about this, but this is one thing that you have to be kind of careful of. It is possible to wind up, since we don't know any of the angles, it's possible winding up with one that that could be, what am I trying to think of? obtuse. I couldn't think of the word. Larger than 90 degrees. So if that happens and you're working with law of cosine, what's going to happen is you'll wind up with a negative value, and that's exactly what's going to happen to us right here, because we're going to get a negative value on top. So just watch out for that while you're working through the problems. Make sure that's not going to cause you any trouble. It's not a bad idea to look for that largest one first. You can do one of two things. You can either go after the biggest one first, which if it happens to be obtuse, then you're going to wind up with a negative number, and so you'll know for sure that it's obtuse. Or you can start with the smallest angle, and then you'll know it's always acute, because really the middle one would have to be 2, because there can only be one angle that's bigger than 90 degrees, and that's the largest angle, which is going to be across from the largest side, which is why this one's winding up being what it is. So let's see. On the bottom we get 720, and let's see, on the top it's 400 minus 320. I'm sorry, plus 2025. 400 plus 324 minus 1156 is going to wind up giving me negative 432 over 720. Divide that by 720. And that winds up giving me negative 0.6, okay? And so if I do a cosine, or cosine for that, my calculator, if you've got a negative value in there, will give you, well, shoot, I messed it up. Will give you the second quadrant angle for that, so it winds up giving you the right one. Angle A is going to be equal to 127 degrees. Okay, so it is in fact obtuse, and that's fine. Now what we need to do is find one of the other two angles. You can go with either one of B or C. It doesn't really make any difference. I'm going to look for angle B next, and I'm going to use law of sines to do it. So I've got a matched set in side A and angle A, and what I'm going to do is write that side A right down here right next to it, so that when I move down I can still see it. I might want to do B too. B is 20 kilometers. Okay. So let me scoot down a little bit, and we're looking for an angle, so we'll put the angles on top. So it's going to be the sine of 127 degrees over 34 is equal to the sine of B over 20. So multiply both sides by that 20 to move it over. Alright, we'll get that worked out and figure out what the sine of B is. Alright, so it's 127 sine times 20 divided by 34. And then I do a inverse sine on that, and I get 28 degrees for angle B. Now it seems a little small, but 127 is a pretty big angle, so I'm not terribly surprised that it's pretty small. And then what we're going to see is that the third angle is even smaller than that, because we saved the smallest one for last, I believe. If I'm thinking correctly, yeah. Side C is not much smaller than side B, so angle C won't be an awful lot smaller than angle B. C is going to be equal to 180 minus 127 minus 28. So let's see what that's going to be. 180 minus 127 minus 28 is 25. So that makes sense. 25 degrees. Maybe a little rounding error from person to person, depending on how you do that in the calculator. So, if you have a little different value, maybe 27 degrees or 29 degrees instead of my 28 for B, that's not wrong. It's just off by just a little bit, and I don't think that's going to make a whole lot of difference on the final. Okay. All right, so that covers our stuff in section 7.2. So get in there and do some work in the homework problems from that section, and I'll post those on Canvas too, so you can take a look and see what you need to be looking at there. And if you got questions, you can ask Thursday.